Jense
Present, sir.
Enamorado. Okay. Joanna Garcia. Joanna Garcia. Kiana Quillen. Kiana Quillen. Owen Martinez.
Present, sir.
Oziel Mendez. Oziel. Vire Novello. Oziel. Aisha Novello.
Present, sir. Sir, tomorrow there isn't going to be any current where I
I
live.
know
So,
we are aware of that. I will just leave some work for you
okay,
to
sir.
do. We are aware of the power outage that will be occurring in the different areas and those who will be affected. So what I will do is just to upload some work. What I'll be doing that time is uploading the work today, the one with the 5 questions that you need to do with the rubric, so that you could start working on that. Are
Okay,
we
sir.
clear? Okay then, Aisha. Thanks for reminding me so that the others could have known. Jonathan Pope.
Yes, sir. Good
Azale
morning, sir.
Ramirez. Azale.
Present.
Elvis Solis.
Present, good morning, sir.
Okay, good morning, Elvis. Jamili Tuyub.
Present.
Okay. So these are the ones that are not. I have some couple of people. Franceli. Asbe. Shanice. Naveen. Joanna and Kiana. Okay, if you're not here, well, I will just save this and begin with what I need to. Okay, let's proceed. Last time we were looking at this particular problem. Before I told you that I'm gonna be introducing you to permutation and combination. It said here that vehicles approaches a crossroad must go in one of 3 directions: left, right, or straight on. Observation by traffic engineers showed that of vehicle approaching from the north, 45% turn left, 20% turn right, and 35% go straight on. Assuming that the driver of each vehicle chooses direction independently, what is the probability that of the next 3 vehicles approaching from the north, I'll go straight on? And then the other one is saying B, all goes in the same direction. Then 2 left and 1 turns right. So part A, let me just put the itineraries here. So this is part A where it said that all, so that you can discern all go straight on. Then part B, all go in the same direction. And part C, 2 turn left and 1 turn, 2 turn left and 1 turn right. And then I'll go in different direction, that's D. I'll go in different direction. And then the last part is exactly 2 turn left. E, exactly 2 turn left. Now, what does that mean going here? Exactly 2 turn left.
Sir, the 2 of them are returning left, sir, only left.
Yes, they must have exactly 2. It cannot be all of them. It said exactly 2. So which will be the different combination then?
Sir, wouldn't it be like the probability of L intersecting like right, and then the next one would be like L intersecting on next direction, sir?
Yes, so what is it? We have the direction here, we have left, we have right, and we have straight on with S. So if 2 goes left, then the other goes right, or 2 can go left and the other one go straight on. And then we need to see how many combinations that we could make from that. So the exactly 2 turn left. Let us have that the probability of G is equal for exactly 2 turns left. So we use G as the event that exactly 2 turns. So this will be one combination I will be showing you. So that will be the probability of left and left intersecting right. And plus the probability, I just going to put the 2 options here, that we have both of them turning left and left, and the other one going straight on. Now, if you notice, this can be arranged in 3 ways. This could be arranged in 3 ways. So just let's look at it. So I will be having this here. Copy. So let's list the different options here. We have one. Then what could be the other probability?
L intersecting R intersecting L, sir.
Okay, we can have L intersecting R intersecting L.
Sir, we can also have as R intersecting L intersecting L.
Yep, that's the third option for this one. So like what you said a while ago, so we could have a left or a right, sorry. We already have that, intersecting L, intersecting L. Everybody agrees?
Yes, sir.
Then in the case of the other one, copy. This is one option. Then the other option will be left. Let me just put it and just write it down afterwards. What's the other option here? So we go left, left, and straight on, then left, straight on, left. And then we can go straight on, left, left. So this is showing you that exactly 2 is going left. Is that so? So in this case here, like I said, I will just find for 1. And then we're gonna be adding up the values. So oh, my phone went and dropped. Anyhow, okay. So we're just gonna get the values right away to expedite. So if we have left, left, and right already shown here, which was 0.8 Okay? All of this will be the same. Let me copy this. For the first one. Is that so?
Yes, sir.
Yes, sir.
And then left, straight on. Let me see if I already calculate any of that. Left, straight on. We haven't calculated that yet in any. Okay. So left, and straight on. So that would be, multiply this for me, 0.0405 times 0.0405. We are multiplying it. And then times straight, which is 0.35. So it's gonna be, sorry. Excuse me. It's gonna be 0.45 times 0.45 times 0.35. What do you get? Zero 0.45 times 0.45 times 0.35. What we get?
0.070875.
0.
0.070875.
07. What goes after the 07?
0875.
Everybody agrees to that?
Yes, sir.
Yes, sir.
Okay. Since you do agree, then I will have this here, and then I will have this here. Okay. So we have 1, 2, 3, 4, 5, 6. So when we add up all of these together, what will be our answer? Excuse me. What will be the answer there? All you need to do 3 times 0 plus 3 open bracket 0 times 0.070875, and then you get the answer.
Sir, I got
What do you get?
0.22275.
0.222
0.22275.
Everybody got that? The others, I need some confirmation.
Yes, sir, it's correct.
Okay. So that is it about this problem here. And remember, this also can be done using the tree diagram. Okay? Is that clear to everybody?
Yes, sir.
Yes, sir.
So how this would have been done using the tree diagram?
Wouldn't it be like 3 branches, sir? The right, left, and then the straight one, and then you just like insert the values, then you minus 1 from the values that they are giving you, so that
Yeah.
you get the answers.
Yeah, so you're gonna be having like what you said indeed. Right? You're gonna be having like 3 branches. Okay. So you're gonna be having 3 branches. Three branches like that. And then one will be, this will be left. This will be right. And then this will be straight on, right?
Yes, sir.
Then here we can go another tree branch. Then for the second vehicle, then the other one, we could have another tree branch. Just to show you more or less how it may look. Then a tree branch. Then the last one will take another tree branch. Then this will take another tree branch. Just to show you something, then this one, I should have tried that bigger and then look at it, but I will not be doing any work here, just to show you something. And then the others will have another tree branch, each of these. Is that clear to everyone?
Yes, sir.
Right? So all of these will have 3 branches. All of this will have 3 branches. All of these will have 3 branches. 3 branches. And just put it here, I should have spread it out more. But it's just the idea. Okay? And then from there you could do, this would have been for the second branch. Here would have been the left. Then this would have been right. Then this would have been straight on. Everybody agrees? And then you do the rest down, then this would have been left, right, straight on, and then you do the rest for the same. Left, right, straight on, left, right, straight on. And then we could have done it by the probability tree. Okay. Any question based on this question? Okay. What I want you to do right now, and we're going to be checking it. It is not something that I'll be grading from you, but I expect you to do it right now. It said it is estimated that 1/4 of the driver on the road between 11 p.m. and midnight has been drinking during the evening. If a driver has not been drinking, the probability that he will have an accident at the time of the night is 0.004%. If he has been drinking, the probability of an accident goes up to 0.02%. Now, first of all, I would like you to do this by means of calculations, then by tree diagram. So for part A, so what you can do is to do it by tree diagram first. Draw a tree diagram to present the data. B, what is the probability that a car selected at random at that time of the night will have an accident? And C, a policeman on the beat at 11:30 p.m. sees a car run into a lamppost and jump to the conclusion that the driver has been drinking. What is the probability that he is right? Okay? So do it by tree diagram first, and then by means of calculations. So start working on that. I'm gonna be muting my mic. I will be here. So if you have any questions, then feel free to ask.
Okay, sir.
Okay. Good morning, class. Good morning, students.
Morning, sir.
Good morning. Okay, I know you're working tomorrow. That will be, in fact, when we meet again, that's on Friday, we're gonna be looking at the solution for this question. So make sure that you do the two ways that I have mentioned it to you. First, by using the tree diagram, and then by using the probability laws and rules. Are there any questions? Because if not, then I'll be ending the class here.
Sir? Sir, the five
Yes,
problems,
Elvis?
the five problems you will be providing us today, when is the due date?
Oh, it will. In fact, remember when I upload it on Google, and you will see the due date and what have you. Okay?
Okay, thank you.
Okay. Any other questions?
No, sir.
Any other questions? Okay. Remember tomorrow, like I said, I'll be setting up sending work today, because remember I told you earlier that some of you won't be having power. So I'll be uploading some work today. Okay. Have a nice day.
Thank you, sir. Same.
Have a nice day to everyone. Okay.
Likewise, sir.